Next problem involves, so this is the probability problem actually. Out of 80 students in a certain class, 12 own a bike and 70 own a scooter. Okay, so we can actually just already start with our probability map essentially. So we can draw some circles here. And I want those circles to be hollow. Okay, we're gonna have two overlapping circles, of course. And we know that there's 80 students total. Okay, so we want, remember with this there's four, we want everything to be added up to 80 students. There's 4 quadrants. There's there's B for bike, only a bike, exclusively the bike, 70 own a scooter. Okay. And then the intersection is bike and scooter. And then this one is the empty space around it, which you can't forget, is no bike or neither bike nor scooter. If students, so okay, 12 own a bike, 70 own only a scooter, and then 5 students don't own either. So 5 would be, remember, that outside category, outside of the 2 overlapping circles. What fraction of the students own both a bike and a scooter? Okay, this one's not that bad because you can just do 80 minus 12 minus 70 minus 5. Okay, let's try that again. So 80 minus 70. Oh, you know what? Maybe they're doing some overlapping. Okay, we can't actually use that. No, we cannot because 12 own a bike and 70 own a scooter, but what fraction own both, we don't know because it's not. I thought when I said 12 on a bike, it's only exclusively the bike and 70 exclusively the scooter, but that's not the case necessarily. We can't necessarily assume that. Okay. Well, of course, you can't have 41 over 40. That's impossible. Remember, because every probability always has to be equal to or less than 1 by definition. Probability of any particular event. So it's impossible that it's 41 over 40. 12 on a bike and 70 on a scooter. So both a bike. So we're trying to find what this is. This number here, this overlapping event. Isn't the equation for that? Right. Remember, this was the expression. The overlapping was the upside down U. I think this was the. Wasn't that the equation? I believe. I think so. See, overlapping. Right. Okay. Here we go. Probability of A or B. We don't want A or B. We want A and B. Probability of A and conditional probability of A and B divided by. But they're independent of each other. We don't. It's not conditional in this case. So that would be. Probability A times probability of B. Probability times probability of B. Okay. Oh, I'm overthinking this a little bit. Okay, so this is not the case. I apologize. Let me go back a little bit. I think what you can do, can't you just multiply them? Because we know that. So when they say probability, it's like this: probability of bike and s is equal to probability of bike times probability of scooter. You can just, but the probability of bike it's including everything. It's including bike and those who own a bike and a scooter. That's also included for the probability to be this total, right? So I think we can do that because we know 12 own a bike and there's 80 total times and 70 own a scooter. It can, and they're allowed to be overlapping because we're only trying to find this part, right? Yeah. If you have to multiply them, yeah. Let's try that. 70 over 80, whatever that is. 12 times 70. 840 divided by 6,400. Whatever that is. 840. Okay, now. So 0.13125. Ooh. Really? Okay, hold on. 80, 6,400, and then you have 840, 7, 12, and 70. 12 times 70. 840 divided by 6,400. 0.13125. Okay. No, 13125. That's what I'm getting. I need to find the fraction that matches that. If there is one, 0.15. It's not 7/8, 7 over 80. No, it's none of them. Okay. 3 out of 20. So 3 out of 20. 0.15. 7/8 is point. Is it 875? Yeah. And then 2 divided by 13 is 0.1538. And 7 over 80. 0.0875, okay. I can get any of those. Look at this again. Um, or the other way you can do it. Bike and scooter? Oh, but it says both. That's why it's not one or the other. It's not one or the other, though. Well, another way you can do this, let's think there's another way you can do this. Okay, so this equation here, probably have A or B. Let's try this one. We can try this other alternative way. If we're not getting anything that's matching one of the answer choices. Okay, so basically you can say then probability of bike or scooter is equal to the probability of the bike plus the probability of the scooter, which we're not concerned with, but then there'll be the probability, which we are probability of bike intersecting with scooter, which is what we want. We have everything else. Bike or scooter, it's 75 out of 80 because it's given. 75 either own a bike. It says it right here. Well, 5 don't, right? So probability of bike, therefore bike upward use scooter is equal to 75 out of 80, because it's just 80 minus 5 equals 75 over 80. Because only 5 own neither, but 75 own one or the other. Let's try this. So then this will be equal to 12 out of 80 plus 70 out of 80 minus probability of bike, or the intersection, basically, minus the intersection. Because remember that we don't want it to be counted twice in our probability event. So probability of bike and scooter both, it's 75 out of 80 minus 12 out of 80 minus. But see, we get a negative answer, which makes it confusing. Actually, maybe this way. 70 minus. Well, no, it'd be plus and. No, actually, this might work, actually. Because you have I did the math wrong. Plus the 12 minus 75 over 80. So 75 plus 12 minus 75. That actually, I think that comes out to a positive number. 70 plus 12 minus 75. 7. Okay, 7 out of 80. Which I think was one of the answers. Yeah. Okay, E. Here we go. We got an answer. Both is only, it's only about 8% of the students. Interesting. I thought it would be higher. Only 12 of them own a bike, so it kind of would be kind of low, because only 12 out of 80 only given that, which is like a little bit more than 10%. That's it. But then 70 own a scooter, so a substantial amount. Okay. Makes sense. Let's see if that makes sense with the answer. So I got E. Okay, jolly good. Everything is jolly good here, so we got the right answer. I mean, okay, it makes sense conceptually, because only about 12 out of 80. What percentage is that? Only own the bike. Only 15%. It's nothing. But then the vast majority do own 70 out of 80. That's 87%. So if you cross kind of 15% and 87% to do a rough calc, you do get 13%, which is pretty not too. I mean, well, that's one of the answers here, but that's wrong. But you see how that's wrong, because you have to subtract the intersection between them. Remember we talked about that in probability? That's why you have the minus the intersection. Or sorry, not the intersection, the whole. Yeah, the intersection. Yeah. Yep. Because otherwise you'll be double counting it. Okay, so that's what. So just be careful. Just make sure to follow through with the whole equation. You do need to know this. I would kind of memorize this if this is given. I don't think this is given in your reference sheet anyway, so I would kind of memorize that. This equation here. It's kind of useful. It was really useful for this one. Otherwise, I don't know how you would have done this problem. You would have probably gotten the wrong answer. Probably a lot of students would have gone, honestly, as a distractor answer, would have gone for this one, because they just multiplied 12 over 80 times 7 out of 80, but then they forgot. See how I got that? It's pretty close to this, but that's wrong. So make sure to follow through with the actual whole equation. Solve it methodically, otherwise you'll get the wrong answer.